Hello and welcome to this tutorial. Today I'm going to be showing you how to perform partial differentiation. Okay, and it's a lot simpler than one might think it is actually. You're dealing with all these sort of fancy symbols and it's not hard at all. And I'm going to show you how it's not hard. Okay, so let's come up with an example first of all. Okay. Call this example 1. Now imagine I've got an equation, right? I'm going to say y is equals to 3x squared plus 2t. Now the question asks, find the partial derivative of y with respect to x. So all we're doing now is we're treating this term here as a constant, okay? So the term that has a t in it, we're just treating that as a constant. So we're pretending that this is a constant, okay? Well, we're essentially pretending that it's a constant. So then the partial derivative of y with respect to x, and then you differentiate as normal, and that would give you 6x. And as I said, that differentiates to 0. For completeness, I will put plus 0 there. Now, let's say it asks, find the partial derivative of y with respect to t. Okay? And very easy now. Just do partial y over partial t. And obviously we're treating this term as a constant. It doesn't matter if it's got x squared over it. It could be any number squared. It doesn't matter, right? Because we're treating x as a constant in this case. And obviously, if you differentiate 2t, it's going to be left with 2. Okay, and that's it. That's all partial differentiation is. It's not that hard. It sounds complicated. It really isn't. Let's go through a couple more examples. We'll just change things up a little bit now. We'll make it slightly harder, although it's not going to be much more difficult than what we've already done. So let's say y equals 3tx squared plus 3x to the 4t squared. Okay, now partial y by partial t, you can say dy by dt or delta y by delta t. I mean, you can say what you want or however you like to say it, but just make sure that you write it like this when doing partial derivatives. Alright, so dy or partial y by partial t, this is a constant, remember that. So we're literally treating this like a constant, alright? And obviously the t goes away, we're just going to be left with 3x squared. Because, remember, this is a constant, so it stays there. In fact, I'll write it out like this. So that's the same thing as 3x squared t plus 3x to the 4t squared. Okay, now we have to do the other term as well because the other term contains a t in it, let's not forget. So what we're doing is we're bringing this guy in front there, just as we do with regular derivatives. 2 times 3x to the 4 is a constant. We take a power off the t, and that just leaves us with 1. T to the 1, because we're just taking a power off. Obviously, we're bringing the 2 in front of 3. Now, I'm sure everyone can see that we get this result here. Yeah, and that's all that is. So now let's do it for x now. Let's partially differentiate for x. partial y, partial x. The t is a constant term, remember that. And obviously we're just bringing that in front there. So that's going to be 2 lots of 3. T stays there, it's a constant term. Just knock a power off the x. There you go. Put them all in brackets to symbolize that we're timesing them together. Plus, okay, so 3t squared, that's a constant. And then obviously we're bringing the 4 in front. So that's 4 times 3 times t squared. And then x to the 3, because we're just taking the power down. All right, and that's just going to give us 6xt plus 12t squared x to the power of 3. And that's it. That's all it is. Now let's do one more, and we're going to now do one involving sine. Yeah, we'll do one involving sine. So y equals cos t. No, I said I was going to do sine, didn't I? Yeah, so y equals sine t. You know what? I'm just going to throw an e to the x in there, so why not? Plus 3e to the x sine 2t. Why not, right? Let's make this hard. So now, partial y over partial x. Remember, we're differentiating with respect to x, which means the sine t we treat as a constant term. So like just a number without any variable attached to it. Right, so then obviously we're just going to get e to the x there, and then that's plus, we're ignoring the sine 2t because, you know, we're treating this as a constant. So that's a constant, yeah? And that's going to be 3 to the x, because when we differentiate that, there's no fact, there's only 1 in front of the x here, so we bring it down, we just get the exponential back. Okay. And me doing this tutorial, I'm just assuming you're comfortable with that stuff. Now we're going to do the same for partial y over partial t, and what we're going to do here is just differentiate these two individually. All right, so the differential of sine t, we're ignoring the e to the x because that's a constant term. Oh, I actually made a mistake, sorry. I was supposed to put these back in there because we're doing a constant term. So yeah, we just get the exact same result back there. Exact same result. So partial y by partial t, what we're getting for that is, yeah, so we're differentiating the sine t, we're treating the e to the x as a constant term. So we're going to get e to the x, which is a constant term, cos t. And now sine 2t, when we differentiate that, we are going to get, because it's a sine 2t, right? We're not dealing with just sine t. So we've got to, when we differentiate that, just got to apply the chain rule, and that's it. So whatever's inside the brackets, let's put some brackets there. So whatever's inside that, we just take that out first. So it's 3 to the x, and then that will be 2 cos 2t, yeah? And that's just, we just differentiated that, and we just put it there. So that gives us e to the x cos t plus 6e to the x cos 2t. And that's it. That's the tutorial on how to do partial differentiation. If you need any more tutorials or any more requests, then if you've got any more requests, then feel free to ask me down below in the comments, and I will do my absolute best to, hopefully make that happen. Good luck, and see you later. Bye.